Welcome to today's FDTD Satellite Applications webinar. Today we're very happy to have Dave Riddell and Brian Haynes join us for today's presentation. Dave is from WFO New York City and Brian is from WFO Philadelphia Mount Holly. The title of their presentation is Post-Tropical Depression Ida, Forecasting and Messaging a High Impact Event with the Aid of Satellite. Next slide. All of these are recorded and posted onto the visit web pages shown at the URL here. Also, we're looking for speakers. If you have an interesting case you'd like to show in the future webinar, either contact myself, Dan Bicus, or Scott Lindstrom, and our email addresses are shown below. Next slide. We'll have about 20 to 30 minutes for our speakers, and we will have a Q&A period at the end of this. So if you have questions, you can put them in the questions or chat box, and we'll have an open discussion at the end of this. We'll be done around 18:30 UTC. Just remember, don't press hold if you're using the phone and mute when you're not speaking. With that, I will turn it over to Dave.
Okay, good afternoon, everybody. Brian, my partner in crime, and I are going to tag team this. So I'll take the first section, and then we'll turn it over to Brian. But object today, obviously, is post-tropical depression Ida, and we'll go through kind of a summary of the event and how the aid of satellite could be used in terms of helping to message and helping to initially create the forecast for this sort of tail of the distribution type of event. So we'll first start with the event overview. Many of you probably remember this making big news back in September. Extremely heavy rainfall, pretty much overspread much of the Northeast during the evening of September 1st, continuing through the early morning of September 2nd. And this resulted in widespread catastrophic flash flooding across much of the I-95 corridor. And the focus today will be basically from Philadelphia up to New York City, where we had obviously hundreds of reports of flash flooding, road closures, subway closures, water rescues, pretty much the whole gamut. So very impactful event. And ultimately, within our two service areas, 54 people died as a result, including 13 alone in New York City. And many of those were a result of the basement apartments that are at street level or just below street level, causing issues for folks trying to heed the warnings. Here's some pictures. The one on the upper left is from Staten Island. We saw in the middle there, again, an example of an apartment that was flooded out. And in fact, even some of the videos that we were sort of watching in real time that night, you're not going to be able to hear this, but this will give you sort of an idea. Let me see if I can zoom this in of kind of what the scenario was like if you were out and about that evening. And this is the old B-57 in Brooklyn. You can see this is water is up to the seats, and people are standing on seats as the bus continues to go through and drive through this flooded out roadway. So again, let's see here. All right. Part of what didn't make, at least up this way, quite the, let's see here. I got this video is still playing. We're going to turn that off and we're going to go back. Okay. In addition to the catastrophic flooding that occurred across much of the corridor, there's actually, there was a pretty potent severe weather threat this evening as well. We had a total of 7 tornadoes across the area, 5 in Pennsylvania, 3 in New Jersey. One of those was an EF3, 2 EF2s, 3 EF1s, and an EF0. So you can see the red outlines here kind of showing the gamut of where most of those occurred. And most of these, all of these actually are in the Mount Holly, Philadelphia county warning area. They're just north of Trenton and kind of extending back to the southwest into southeastern Pennsylvania. The Mullica Hill was the EF3. You can see here on the upper left picture of some damage with a brick structure there leveled, and you can see the path on the right. Estimated peak winds there of 150, and it was on the ground for almost 13 miles. So just to give you kind of another sense of some of the severe weather that was associated with Ida's remnants. If we take a look here quick at kind of a radar summary and the kind of an overview of the warnings from the tornado to the flash flood, you can see that for the most part, as time went on, and this is about a 4 to 5 hour frame here, that basically in most, essentially both CWAs were papered with warnings throughout the evening. So again, in terms of impact, very high impact event as this unfolded. And now we'll turn it over to Brian.
Hey, thanks, Dave. It's Brian. Can everyone hear me?
Yeah, you're good, Brian.
Thanks, Dave. Yeah, so as Dave already alluded to, Ida was probably one of the most impactful events we've had in the Philadelphia area, New York area in some time, many years. And I think, that's saying something. 2021 was a really impactful year here in Eastern Pennsylvania to New Jersey, New York. The Ida was coming on the heels of July 29th outbreak. We had 10 confirmed tornadoes on July 29th with another EF3 on the 29th. For Ida, what made Ida so impactful was, in total, between our two offices, we issued 19 severe thunderstorm warnings, 18 tornado warnings with 1 tornado emergency, and we issued 25 flash flood warnings with 7 flash flood emergencies issued for the area. River gauge wise, we have 49 gauges across the Philadelphia area. 46 of them went into flood and 30 of them went into moderate or major flooding. So definitely an impactful event, flash flooding and severe wise. Next slide, please. Yeah, so here's the WPC excessive rainfall outlook verification. Alex made this for me for WPC, and I wanted to include this just to see this breadth of amount of reports is just staggering. And what you're looking at on the left-hand side, this is the day 1 excessive rainfall outlook that's issued by WPC. This is basically, the forecast the day of, and the light green line, that is your marginal risk. The golden is slight, the red is moderate, and the pink is high. And in total, we issued 345 flash flooding reports across both of our areas, and just really a tremendous forecast by WPC. On the right-hand side, you can see the forecast that would have been generated from a practically perfect analysis, meaning if you had the answer and you made the forecast, what it would look like. So really pretty impressive forecast by WPC. Great job there. And just the amount of reports was staggering. Next slide, please. Yeah, so on this one, this is the MRMS QPF total. So we had a really impressive stripe of heavy rainfall. This extended from the Philadelphia to the New York City area, a swath of about 6 to 10 inches of rainfall just right around the metropolitan areas. We had 2 reports of over 10 inches of rainfall. That was in Chester and Somerset counties, with the 9.5 inch rainfall reported in Midtown and 9.1 inches in Nassau County. And on the next slide here, we're going to take a look at the average recurrence interval. And if you've taken a look at MRMS ARI before, I don't really think I've seen this breadth of a 200-year return before. And just to put in perspective, I did a back of the envelope calculation here for the total square miles, and that 200 encompassed by the 200 return interval, and that's your really bright pinks on this image. And if you notice, that covers a lot of the population right along the I-95 corridor. It's about 3,500 square miles is encompassed by that very bright pink purple color shading, just to give everyone a sense for the sheer breadth of the flash flooding that was being reported across the area. So then at LaGuardia, we had we pulled the 1-minute ASOS data. This was from Dave, and estimations of 3 to 4 inch per hour rainfall rates. This is just something you don't see normally around here in this neck of the woods. Rainfall total approaching 7 inches. Really impressive. Take a look at that 1:30 to 2:30 Zulu time frame right in the center of the graph. That's when you're getting just hammered with rainfall, about 3 to 4 inches per hour rainfall rates. So synoptically, what sets the stage for this to happen? So as we go through the next couple of slides, we're going to do some upper air maps, but then we're going to have Dave talk about also how we can see that on water vapor, and we're going to relate and link the two. And I think that's one of the key points in our talk here is that a lot of things that we're seeing on radar and the upper air analysis, you need satellite to help aid you in your mesoanalysis and targeted threat assessment. So here's the 250 millibars. This is observed at 0Z on the 2nd, and notice that strong upper level jet streak across southern Ontario, Quebec. It's amplifying and strengthening, and that puts strong upper level divergence right over the PA, New Jersey, New York area. We're right in that right entrance region or right rear quadrant of the upper level jet streak. And also notice that deep southwesterly flow across the area, really helping to aid bringing that deep Gulf moisture across the east coast of the United States. At 500 millibars here, again, here's your short wave across Ontario, Quebec, digging down all the way towards the Gulf Coast of the United States, Ohio River Valley. Dave's going to show this nicely coming up here on satellite. And notice that 50 knots measured at Brookhaven or New York City. And that's going to be in a yellow arrow that'll pop up here in a second. And this is really impressive. And when we're trying to figure out, how impressive is this, if you take a look at the sounding climatology, that's about the 90th percentile for this time of year. And this time of year being in the September period for when Ida was coming through. And finally here at 850, look at the jet max, 45 knots. Extremely impressive for this time of year. Again, that's near max values recorded for this time of year. So all of these things are trying to tell us something that this is probably going to be a tail of the distribution event. So as we go into the surface analysis, so this is something here that at Mount Holly, I think this is something where we really link the surface analysis with what we're seeing on satellite. And we have a great example of this. So a lot of times here will be initially stabilized in the morning, and then you'll have a warm front pushing to the north, and with a lot of the area being destabilized or warm sectored. And we have post-tropical depression Ida here. This is currently over the Charleston, West Virginia area, and this is at 15Z. And the question a lot of times with these events are exactly how far north and west are the warm front going to make it across the area. And this is something that happens time and time again here. And satellite can really help us in aiding where and how far north that warm sector has made it. So next slide, this is going to be your surface analysis at 0Z. Again, notice that Ida is going to be right over the I-95 corridor with most of New Jersey well into the warm sector. And we're going to be able to visualize that here in a second. So finally, I did want to show the KDIX VWP. I thought this was just too good to pass up. This is from Autumn Sky. If you've ever had a chance to take a look at the website, I strongly encourage it. Not many times do you see this in New Jersey with a surface to 3 kilometer SRH of about 550 meters squared per second square. Very something that you see normally in the plains. But as one of my friends would say, if the meteorology supports it and the atmosphere supports it, physics will everything will always obey the laws of physics, and that sure is what happened here. And if we go forward, we're gonna start diving into the satellite and mesoanalysis. So if we go one more to the next slide to kind of give everyone to where we're at when you walk in on shift this day. So imagine you're walking in on shift at the New York City, Philadelphia WFO. Here are your outlooks. SPC outlook is on the left. This is your day one outlook. Notice the enhanced risk over New Jersey with a slight risk trailing from North Carolina up towards Connecticut, southern Massachusetts. That day one enhanced did include a 10% TOR prob, mirroring the enhanced, and then you have a high risk on the right from WBC day one across central PA, northern New Jersey, and into New York City. So if you take a look at the next slide here, here's going to be your soundings, and really take a look at that SRH. Again, 390, really strong curvature, winds turning with height as you go up in the atmosphere, and look at the strength of the flow. Strength of the flow, deep southerly flow, southwesterly flow, all the way from about 925 all the way up through 300, 200 millibars. Really impressive wind field. And if we click again, so PWatt here is over 2 inches. And if we click one more time, just to put on perspective where this is located again, we're in the day one excessive rainfall high risk, and this is approaching, this was actually a daily record for OKX. But for the just for overall this time of year, you're taking a look, this is approaching the moving max for this time of year. So definitely we have all the ingredients in place: strong wind shear, we have a destabilizing atmosphere with high precipitable water values in place for a potential tail of the distribution event. So if we go to the next slide here, we're going to take a look at the mesoanalysis, and this is where really I think satellite and satellite and operations comes and links, and we can synergistically use each. So if you remember, this is the SPC Mesoanalysis, and this is based off the RAP data. And this is a good first estimation, but we really want to then dive into the satellite data. And what I'm going to focus on here is if you just look big picture, on the left-hand side is most unstable Cape. And you can see that we're warm sectored across most of the area, but the key is, is the RAP really picking up on everything that we're seeing properly with the extent of the warm sector. The middle parameter is the 0 to 1 kilometer SRH. So again, shear values are off the chart. The helicity values are off the chart. We're definitely fine when it comes to if we have enough shear across the area. Then on the right-hand side is your precipitable water plot. Again, 2-inch plus precipitable water is near record value for this time of year. But satellite can really help us break down exactly the extent of the warm sector and then the distribution of the moisture through different layers of the atmosphere. So if you go to the next slide, this is something that I've used a couple times in ops, and it's basically a best practice, I'd say, at our offices, really trying to use either the day cloud face distinction or visible, just to really get a feeling for the extent of the warm sector. And what I've circled here are some horizontal convective roll clouds, HCRs. And again, if you remember, that's really indicative of a mixed PBL, free overturning occurring in the atmosphere. Remember, your HCRs are going to be parallel to the low-level shear vector, which I've plotted on the right for the RAP. And if you notice, it looks like the RAP's maybe a little bit quick with the turning of the low-level shear vectors. And then also, you can see the extent of the warm sector. You can see it extending to right about the Pennsylvania border towards central and northern New Jersey. And this is a really good sign indicative of that we have plenty of instability here across central New Jersey. Again, like I said, the PBL is well mixed. You have free overturning. We have good shear. We've already talked about it. So this is definitely something this area is definitely where we're going to keep an eye on things. In particular, that interface where all three overlap is going to be somewhere across southwestern New Jersey. And if we go forward, the next slide here, sure enough, this is where the Mullica Hill tornado formed. And this is just a quick radar snapshot of what it looked like. This is what I call the old-fashioned TDS, just based off of the legacy radar products. You can actually see the TDS just from the reflectivity here. It almost looks like a three-body scatter spike that you'd see from hail, but that's debris being lofted. On the right-hand side, this is a cross-section of the reflectivity with the CC, and you can see that correlation coefficient dropout circled in the black line. This is debris being lofted. We were able to see the debris signature about 16,000 feet. Really pretty impressive for anywhere, but in particular New Jersey. So with that, I think I'll pass it back over to you, Dave.
All right, thanks, Brian. Can you hear me okay? Just to check.
We can hear you, sir.
All right, sounds good. Yeah, one of the challenges, of course, with this event, this has been pretty well documented. There was a model evaluation group, I think a couple of seminars on this in terms of model performance, in terms of the axis of the heaviest QPF associated with IDA. You can see here on the left, these are 12Z, both 12Z runs here of the HREF on the left, the HRRR on the right, from the morning of the event. And you can see this on the left here, we have the HREF probability of more than 3 inches in 3 hours, as well as the mean QPF kind of underlaid there. And you can see heaviest access really kind of spans just north and west of New York City. And the same on the right with the HRRR runs, the HRRR run that night actually. So it's about the night before rather. So you can see kind of, I've outlined the position of the warm front approximately so, kind of just over the island, just south of the island of Long Island. And you can see the heaviest precipitation there in terms of an hourly amount exceeding 2 inches just north and west of New York City. In these kind of situations, whether that heaviest access is just north of New York City in the urban corridor or just over, kind of makes all the difference in terms of impacts. And so this sort of northwest shift was something, this northwest bias in the models, I guess one could say, for this event was something that was noted. Going back to some of the water vapor, you can see here from channel 8 a couple of features to point out. This is a couple a day. This goes through the day on Wednesday. You can see, of course, the upper level feature diving down over the Ohio Valley. Also point out kind of on the lower right here, an upper low kind of sitting off the southeast coast, retrograding back to the west. Didn't actually even notice that until we were going back through some of this data. but maybe help to kind of focus and streamline some of the significant moisture advection that occurred here out in association with this event. So even, going back through some of this information, some of the things that pop out are kind of phenomenal. One way to kind of look at some of this, and we show it here in a 4-panel, Brian mentioned the day cloud phase in the lower right. But again, kind of looking at some of the components of the day cloud phase, and basically the clean IR in the upper left and the channel 2 viz in the upper right kind of show exactly what you would expect from what Brian pointed out in the day cloud phase. You can see as time goes on by Wednesday afternoon, you can see some of the clearing down there over parts of southern New Jersey, and you can see up to the north as you get towards the city, those higher level clouds kind of maintain some persistence there. So you can see kind of thinking about the position of the warm front kind of remaining, over or just to the south of Long Island as the afternoon of the first wore on. This is the perfect example really to kind of highlight the utility of the layer precipitable water product. And so upper left, what this basically does is take the entire troposphere and section it off into where you might be seeing the most contribution to the precipitable water. Surface 850 on the upper left, 850 to 700 on the upper right, 7 to 500 in the lower left, and 5 to 300 millibars in the lower right. And I've tried to sort of superimpose at least the position of where the upper front might be associated with this. And you can kind of see discontinuity there in the moisture field, indicative of that. As we go along a little bit later on in the afternoon, that was 15Z, now we're at 0Z. So Wednesday night, as the event is sort of unfolding, and you can pick out essentially at least 3 different sources of moisture kind of all contributing to those 2-inch plus precipitable waters that we mentioned before. You have, at least at the lowest levels here, a couple of different branches sort of all focusing up along the East Coast. And then as you go a little bit higher up, you can see in association with the upper low, kind of even an additional source of moisture that's helping to feed into parts of the Northeast. And in fact, you can even see, at least with the kind of main flow, the main channel here, it's evident at all four layers. And so this just, sort of solidifies in your mind how deep and how potent, I guess you could say, this moisture actually was that was being transferred up into the east along and ahead of the system. If we put it into motion, this is over a couple of day periods. This actually starts late on the day before and goes. You can see there's the upper, there's Ida, at least the low and mid reflection of it. And you can see those channels that I sort of pointed out in the last slide all starting to come together right about here. And by 0 to 3Z on Thursday, begin to, we'll do it one more time here, begin to show those contributions to each of those layers kind of focused right on the I-95 corridor, and then again during the last few images there up into New England. So we'll let that play one more time. Right about here. Just very impressive. So if you're wondering again where you might find this, this is a supplemental product that's pulled through by the regional LDMs. This can be set up in the data add-ons manager piece of AWIPS. So it's called the CIRA ALPW. And again, all I did was just make a 4-panel there and save it as a procedure. But it's one that, in terms of heavy rainfall potential, can be used to sort of track back trajectories of your moisture sources. Some additional things, again, that are worth looking at. You can see this really well in terms of the horizontal convective rolls that Brian mentioned before with the sandwich, the Viz IR. Taking a look at the combination, you can even see there towards the end some of that making its way up towards Long Island in the first part of that shot. But this also allows you to see pretty clearly the combination of those, cooling cloud tops, minus 60, minus 70 or so is those deepest reds that you see as things start to move up to the northeast. But you also can see the individual towers in there, almost convective towers, by overlaying or underlaying, in this case, the visible section of that. So it's a good example of utilizing the sandwich RGB to help identify those cooling towers and this sort of most intense convection that's embedded within this larger piece of the entire system. You can also put GLM over that. That's one thing that I like to do when you're looking at these wider views. Again, you can toggle these. I personally will either toggle them on and off, or even have them flashing more so than they already do, to kind of eliminate some of the over coverage with it, or set it so that it's only above about 4 to kind of eliminate some of that. But you can see just the amount of lightning with this thing. I'll play it one more time. That is those individual embedded piece of convection, quite a bit of lightning associated with this as well in this somewhat tropical environment. So fairly persistent in there for a period of time. And this is over about 5 or 6 hours, I believe, during the entire loop. So the messaging, again, this was one event that was messaged pretty well, starting on that Sunday and Monday, even before the Wednesday evening. And again, both from before, during, and after, highlighting kind of what we knew and what some of the uncertainties were, trying to put some of this into context with other high-risk events in terms of flash flooding that we've had. And so trying to put all of this together into the way in which we message and sort of threat target these types of situations. So to summarize, again, in these kinds of situations, satellite can provide that extra confidence in moisture analysis. Again, in addition to some of the convective destabilization, and again, this is in a post-tropical kind of transitioning environment, where you have this deep convection embedded into a larger scale, almost tropical-like environment. In these hourly layered precipitable water value imagery can sort of help with analyzing the source region. Where do you have, and at what levels do you have most of those contributions to the moisture source for your particular event? Again, global model guidance showing the area of max precip northwest of New York and Philly. Again, that's been pretty well documented. But is there a way, and can you use some of this shorter fused information to help diagnose and kind of position where your features are, where the position of the front is, and those sorts of things to sort of help, as we saw with some of the sandwich and IR shots with the GLM overlaid, that in fact you could see the trajectory that heaviest precipitation was certainly going to fall to the south of where the guidance had been pinpointing it over the last several cycles. And that GLM with a sandwich plot, again, especially if you're zoomed out in a multiple CWA kind of environment, provides that nice view of the developing and deepening convection. In this case, that's embedded within a much larger precipitation complex. And either blinking or toggling that GLM off and on through time, that's a personal preference, can give you a little bit clearer view of things as they're unfolding as well. So with that, Dan, I'll turn it back to you for questions, discussion, however you want to proceed.
Thank you, Dave and Brian. So at this point, I'll take any questions or comments. So we have the question box where you can type in your questions. Also, if you would like to just talk, maybe you have a longer question, just let me know and I'll make sure you're unmuted so everybody can hear you. So yeah, at this point, we'll take any comments or discussion or any questions for Dave and Brian. I'll just make one comment here, give maybe some people more time. The ALPW product you mentioned will be available on the SBN for next year. That's the planned schedule for it. And up until that time, like you said, it is available via LDM feed from the various regions. So not seeing any questions yet. So just give you a little bit more time here. Any questions or comments?
Dan, I do see two hands have been raised. So if you can unmute
Oh, okay.
Mike or Mark.
Yeah, let's see.
And while you're trying to, I just have a comment. I noticed in the band 13, there's a big blossoming of cold cloud tops, like over the lower Susquehanna Valley, that then move northeastward. But I didn't quite see if that was the system that brought the very heavy rain that you showed at LaGuardia. So was it that little mesoscale mesoscale system that you could see in the band 13 around 1920 Z over southeast Pennsylvania that then moved up over New York City?
Let's see, Scott, I recognize your voice. I'm going back here.
So that thing.
Yeah.
But I didn't see. I mean, this doesn't go all the way up to like 1 and 2 Z when the heavy rain was falling. But that sure looks. Looking at that upstream, I'm thinking, yikes.
This is all part of the same complex.
Okay.
I'll get to Mark here in just a second. We got a question from Steve Zubrick regarding the GLM. How useful was the use of the minimum flash area product?
Hey, Steve, good question. Didn't look at it, to be honest, and didn't look at it back for this case either. So I can't comment on that either way. I'm not sure if Brian has anything to add, but didn't take a look back at that.
Yeah, I mean that's a good question, Steve. To be honest with you, the same boat as Dave. We didn't look at it during this event. One thing that we did start doing after this event was you can get the satellite lightning data into GR2, and we started doing that. I talked with our satellite guru at the office, and we made that as part of a best practice to add that place file, I think it is. So that is one thing that we did do to try to give people more opportunities to take a look at it, but not for this event.
Okay, we got a question from Luis Rosa. Under the GOES full disk menu, there is a product called RR/QPE. That's rain rate/QPE. Was that used or compared with the Precip reports?
Yeah, Louis, that's a good question. I guess I don't know. I don't believe we looked at that. We were at the time relying mostly on radar. Is that I actually don't remember. That is a national product, or is that a regional supplied product? Not that it matters, I guess, but we did not use that in real time.
Yeah, this is Scott. I've talked to Bob Kulagowski about that because that's the GOES 16 rain rate level 2 product, and it underperformed for this particular event, and he's trying to figure out why. And I know that the rain rate product is being updated. So the product that's in AWIPS right now is not the enterprise product. So that's being rolled out in the near future.
But Louis, you make a good point. I mean, this is a case too where you would want to have, something like that overlaid as part of your, overall situational awareness. I would think that would be a great thing to have overlaid if you were confident, certainly if you were confident in the output.
Okay, Mark DeMaria has a question. Mark, I unmuted you, so go ahead and speak.
Okay, yeah, sorry about raising my hand. I was having trouble getting the chat box to work. I was just wondering if you used any of these more exotic satellite imagery like the sandwich product in IDSS for external users, or whether those you use mostly those internally to make the forecast.
Yeah, hey Mark, it's Dave. Yeah, I mean, we've not made, at least our office has not made use of those products externally. We've kept it mostly internally. What I will say is that when we are deployed on site, our folks, myself included, will use this stuff as part of that process. But in terms of including it in something like an IDSS briefing or on a webinar, we've not made use of any of the RGB-ish products for that.
Okay, yeah, I was just curious how it would be kind of a challenge to explain something like that, especially in a short briefing. So I just wondered if you had tried it before.
Yeah, and you've hit the challenge on that one. Is oftentimes you have 5 minutes, so
Yeah.
you can't use 4.5 explaining the product.
Yeah. Okay. Thanks.
Okay, last call. Any other comments or questions? Okay, well, hearing none, we want to take this opportunity to thank Dave and Brian for today's presentation. And just another reminder, if you do have an interesting case you'd like to show in the future, just contact myself or Scott and we can get you scheduled for a future webinar. Thanks, everybody, and have a great day.